Good to you, students. Today we'll be dealing with chapter 5.5 under forces and matter, how to calculate prayer. Let's start the class. Definition of prayer. A large force pressing on a small area gives a high prayer. Prayer is the force per unit area acting on its surface, which can be written as prayer is equal to force divided by area. Force is represented with F, while area is represented with A. Prayer in itself is represented with P. That's why we have P is equal to F over A. Prayer is measured in Pascal or Newton per meter squared. 1 Newton per meter squared is equal to 1 Pascal. Now, let's deal with this activity. We have to calculate the prayer exerted by a woman dancer when 600 Newton standing on a single hill of area 1 centimeter squared. If the surface of the dance floor is broken by pressures over 5 million pascals, will it be damaged? First, before we answer that question, we need to state the parameters, calculate the answer, and then bring it out to see what our option would be. So here now, I have prayer to be equal to what? Force over area. And the area here now is 1 centimeter squared. Don't forget that area here now is 1 centimeter times 1 centimeter. But prayer is measured in Newton per meter squared. That means we have to convert centimeter squared to meter squared. But 100 centimeter is equal to what? 1 meter. Then 1 centimeter is equivalent to what? That's 1 meter over 100 centimeter times 1 centimeter. Centimeter cancels centimeter. 1 centimeter is equivalent to what now? That's 0.01 meters. So if we are to have area, that will now be 0.01 times 0.01. That will be meter squared instead of centimeter squared. Area now will now be 0.0001 meter squared, which you can write in standard forms as 1 times 10 raised to power minus 4 meter squared. With that, our prayer now becomes force over area. What's the force? That's 600 Newton. Newton over 10 raised to power minus 4. 1 times 10 raised to power minus 4 is also 10 raised to power minus 4 meter squared. So 600 can be written in standard form as what? 6 times 10 raised to power 2 divided by 10 raised to power what? Minus 4. If we take 10 raised to power minus 4 up, based on the law of indices, that will be 6 times 10 raised to power 2 plus 4. That's 6 times 10 raised to power 6 Newton per meter squared. So we can say Newton per meter squared is also referred to as what? Pascal. That will be 6 times 10 raised to power 6 Pascal. So we can write it as the fact that our prayer is what? 6 times 10 raised to power 6 Pascal. Don't forget that 10 raised to power 6 is also referred to as what? Mega. That's 6 M, capital M, then PA. But don't forget in the question, we were asked that if the surface of the dance floor is broken by pressures over 5 million pascal, will it be damaged? That is true, it will be damaged. That shows that we have 6.0 megapascal and the floor will be damaged. So let's pick the answer and check. As you can see, that's correct. So let's move on. So we are asked again, number 2, which exerts a greater pressure? A force of 100 Newton, a force of 100 Newton acting on 1 centimeter squared, or the same force acting on 2.0 centimeter squared. Now, the area here now is the issue. We want to see on which area are we going to have the greatest pressure via the same force of 100 Newton. So let me call it here P1. That will be F over A1. Don't forget that our A1 is 1.0 centimeter squared. So A1 now will be what? 1.0 times 1.0 centimeter squared. So let's convert centimeter squared to what? Meter squared. Don't forget that 1 centimeter is equivalent to what? 0.01 meter from our previous calculation. So if I should say now that I have A1 now in meters, that would be 0.01 times 0.01 meter squared. And that gives me the first area now. That is 1.0 times 10 raised to the power minus 4 meter squared. So with that, I can calculate the pressure rather for P1. That will be 100 newtons over, that's 1.0 times 10 raised to the power minus 4 meter squared is the same thing as 10 raised to the power minus 4 meter squared. So by way of standard form, take the denominator upwards. And don't forget that 100 Newton can be written in standard form as 10 raised to the power 2. Then the denominator comes up, that's 10 raised to the power 4. It was negative as a denominator, so it becomes positive as a numerator. So adding 2 and 4 based on the law of indices gives 10 raised to the power 6 Newton per meter squared. So we have 10 raised to the power 6 Newton per meter squared. So let's do that of P2, where our area is what? 2 centimeter squared. Don't forget that if 1 centimeter is equal to 0.01 meter, 2 centimeter will be equivalent to what? Multiplying 2 by what? 0.01 meter. So that makes area now, which is what? 2.0 centimeter squared. So now this one becomes 0.02 meters. So that will be 0.02 times 0.02 meter squared. And that gives area that will now be 2 times 10 raised to the power minus 2. You know, we are multiplying twice, all raised to the power 2. 2 raised to the power 2 times 10 raised to the power minus 2, all raised to the power what? 2. And that gives 4 times 10 raised to the power minus 4 meter squared. So the pressure now for P2, don't forget that 100 Newton can be written as 10 raised to the power 2. Or let me write it first, divided by, now we have 4 times 10 raised to the power what? Minus 4. That will be 10 raised to the power 2. Or, don't let us do it that way, 4 here 1, 4 here 25. So I can fully take the 10 raised to the power minus 4 upwards. That will be 25 times 10 raised to the power what now? Then 10 raised to the power 4. And that gives 25, 1, 2, 3, 4. That's Pascal. So, and for the that's 250,000 Pascal. But for the P1, we have 1 million Pascal. So Which one now exerts the greatest force? That means a force of one greatest pressure. That means a force of 100 Newton acting on 1 centimeter square has the greatest pressure than that of what? Than that of area involving 2 centimeter square. So can we pick it now and check? Correct. So let's move on. Now, pressure, depth, and density. That's the subheading we are moving to now. The deeper a person dives into water, the greater the pressure. Pressure is directly proportional to depth. Pressure also depends on the density of a material. Pressure is also directly proportional to density. The equation for pressure at a depth h and density rho is given as P is directly proportional to the product of height and acceleration due to gravity. Now, the symbol you see there, more or less like alpha, is the constant of proportionality. So we have to drag the following words into the correct boxes. Therefore, what do you think we will pick first? Pressure is the product of height, density, and acceleration due to gravity. So let's check. That's correct. Let's move on. Now, we have to calculate the pressure at the bottom of a swimming pool, 2.5 meters deep. How does the pressure compare with the atmospheric pressure of 10 raised to power 5 Pascal? Density of water is 1,000 kilogram per meter cube. If you don't want to use kilogram per meter cube, that means the density of water now be what? 1 gram per centimeter cube. But let's deal with the question we were asked. Here now, instead of having P is equal to F over A, we will now have P is equal to what? H rho G. Don't forget that P is directly proportional to what? H and what? Rho. That is height and density. Where G here now is the constant of proportionality we see here. Connected to this is equal to. But now we now have P is equal to H rho G. So pressure is equal to height is 2.5 meters times density is 1,000 kilogram per meter cube times now acceleration due to gravity at if not specified here now becomes 10 meters per second square. So let's simplify this. 2.5 in decimal can be written as 5 over 2 in fraction times 1,000 times 10. So 2 here 1, 2 here 5. 5 times 5, 25 times 1,000. That gives 25,000 newtons per meter square or 25,000 Pascal. Pascal is represented with PA. So do we have 25,000 Pascal as part of the option? Yes. So let's pick it and check. That is correct. So let's move on. Now, calculations involving pressure, height, and density. Look at the box below. It shows a tank that is filled with oil. The density of oil is 920 kilogram per meter cube. A, we have to calculate the volume of the tank from the dimensions shown on the diagram. B, we have to calculate the weight of the oil in the tank. And C, the pressure at the bottom of the tank is caused by the weight of the oil. So calculate the pressure using P is equal to F over A. Again, for D, you have to calculate the pressure using P is equal to H rho G. Do you find the same answer? So we solve all that, and I will give you a complete breakdown of how the solutions have been provided in the next stage. But let's show the solution here. So for the A part, we start. All right. So for A now, we have to calculate the volume of the tank from the dimension shown on the diagram. Don't forget that volume is what? Length times breadth times height. Here now, if you look at this diagram below, the length is 2.0 meters times, look at the breadth. The breadth is 1.5 meters and the height of the same shape is 1.0 meters. So volume here now, 2 times 1.5, that should be 2 times 3 over 2 times 1, and that is what? 3.0 meter raised to power 3 meter cube. Now, let's take on part B. Calculate the weight of oil in the tank. Don't forget that weight is known as what? Mass times gravity. But we can't find weight directly like this. We have to go through what? Density. And density is what? Mass per unit volume. We know the volume, we know the density. So mass now will be what? Density multiplied by volume. Mass is equal to, what's density now? 920 times the volume is what? 3. Don't forget mass here is measured in what? Kilogram. So 920 times 3 gives us 2,760 kilograms. So from there now, we can then calculate the weight. Weight here now becomes 2,760 times, take our gravity now as 10 meters per second squared times 10. And that will all be measured in what? Newtons. So weight equals to 27,600 newtons. So for C, to calculate the pressure at the bottom of the tank using P is equal to FA. So let me do it here. C now is equal to P is equal to F all over A. Don't forget that we don't know area, but how can we know area? Area is what? Length times what? Breadth. So our length is what? 2.0 times the breadth 1.5. All in what? What will be the unit? Meter square. So area now is what? 2 times 3 over 2. And that gives 3.0 meter square. But what is the force that is involved? You know that force is equivalent to what? Weight. So pressure is what? 27,600 Newton, all divided by 3.0 meter per 0 meter square rather. So pressure is equal to 9,200 Newton per meter square. So, and that is what? 9,200 Pascal. Okay, so we are also to calculate the pressure using the formula H rho G. So let's try it out and see. For the D part now, I now have P is equals to H rho G. So P now, the height now is 1.0 meters. Don't forget that the density of the oil is what? 920 kilogram per meter cube times, what do I call the gravity? That's 10 meters per second squared. So P now is what? 1 times 920, that's 920. 920 times 10, that's 920 times 10. That Newton per meter square. and that gives 9,200 Newton per meter square, 9,200 Pascal. You will discover that the answer to C and D are all the same. Now let's move on. So the answers have been what? Have been placed on here. You can observe it for some few seconds. You will discover that the answer we have in C is the same as that which we have in D. So let's move on. With that, we've come to the end of the class, but we won't go without having the summary for the day. So let's do these two summaries and check which of the statements is correct. Pressure directly proportional to the area occupied by a surface. The statement is wrong. Pressure is inversely proportional to area, but only directly proportional to force. Pressure directly proportional to the product of the density and the height of specific substance. Pressure is directly proportional to the product of density and height of specific substance. The statement is what? Correct. Where I showed you that pressure is equals to H rho G. Pressure is directly proportional to height, directly proportional to gravity, and directly proportional to what? Density. Pressure is inversely proportional to products of density and height of the specific substance. The statement is what? False. So our correct statement there is that what? Pressure is directly proportional to product of density and height of specific substance. So we pick this, as you can see, is correct. Now, for the second one, let's take them one at a time. The unit of pressure is kilogram per meter squared. That is wrong. The unit of pressure is what? Newton per meter squared, or what? Pascal. Let's take the second statement. The unit of pressure is Newton meters. That is very wrong. The unit of pressure now is Pascal or Newton per meter squared. That is right. So we pick it and check. Correct. With this, we've come to the end of today's class. Do well to join me for another interactive section next time. Do visit our website www.edubbey.com for more of our interactive notes and videos. Do have a great time. Bye.